Hey, Honors Chem, here we go. We're starting the mole. I told you it's a difficult concept. I wanted you to see how we can convert between different units using the mole. And this is going to help with the Poggle that I'm going to push out today, Tuesday, March 31st. Let me get my head out of the way. If you want to convert from moles to a certain number of particles, you're going to multiply by Avogadro's number. You're going to want to refer back to these videos. Here's what I've done. I came up with a random measurement. This is random. This is not on the periodic table. This is out of my head. We're using the element copper. And let's say we have 4.2 moles of copper, and I want to convert to particles. Since it's a single element, and I want to go to particles, my answer is going to be in atoms, because you have atoms of a single element. We need to convert from moles to atoms. Here's how it looks. Notice the fractions, notice the dimensional analysis. This is not, I told you this wasn't going away, but I wanted you to see me do it. What I'm doing right now is going from moles to atoms. 4.2 moles of copper. I wanted you to see me put this over 1. It's in the numerator. That's our initial measurement, but it's in moles. We don't want moles in our final answer. We want atoms. What we can do is we can bring moles down because we want it canceled out. I simply wrote moles of copper. What I want on top is atoms of copper. You can now convert from moles to atoms using Avogadro's number. Extend that a little bit. If you remember a previous video, the one where I introduced the mole, 1 mole of anything is 6.022 times 10 to the 23rd units of that substance. What we're going to do is we're going to set this mole unit, we're going to set this to 1. This is a relationship right here. For every 1 mole of copper, there are, and I didn't give myself enough room, I never do, 6.022 times 10 to the 23rd atoms of copper in 1 mole of copper. So it's a simple multiplication problem to go from moles to particles, in this case atoms. 4.2 times 6.022 times 10 to the 23rd. The answer would be to 2 sig figs, because my initial measurement has 2 sig figs in it. Okay, I just changed it up. Notice I have converting from particles to moles and not the other way around. To do that, we're going to divide by Avogadro's number. I set the problem up the same way. We have an initial measurement right here. I hope you can see that. I made up a random number. This is from my head. 8.42 times 10 to the 23rd atoms of copper. How many moles would that be? Well, we don't want atoms in our final answer. We want it in moles. This part's going to look similar to what you just saw, except flipped. I'm going to put that over 1 because that's our initial measurement, just to show you that it's in the numerator. Atoms is going to be on the bottom, moles on the top. We're going to set the mole number to 1 mole of anything, 1 mole of copper, and down here will be Avogadro's number. I gave myself enough room that time. 8.42 times 10 to the 23rd divided by 6.022 times 10 to the 23rd. Your answer will be to 3 sig figs because of our initial measurement. It would be just over 1 mole. I did this, I wanted it to be a number higher than Avogadro's number, but not too high. The answer would be 1 point something. I should have calculated it, but I did not. Okay, notice I've switched up the example again. This is a lesson on how to convert from moles to grams, because again, we count things by massing them out, by weighing them. We count things that we can't see by weight. So we can actually now we can convert from moles to grams or grams to moles. What we do here is we use the chemicals, the substances, molar mass. You will find the molar mass right on the periodic table. In a previous video, I talked to you about how if I had one atom of an element like carbon, it would weigh 12.01 AMUs. But if I had a mole of carbon, it would weigh 12.01 grams. That's its molar mass, okay? So you can look right on the periodic table, realize that in this example, we're dealing with carbon, and you see that 12.01 on your periodic table. Just stick a G after it because its molar mass, the mass of a mole of carbon, is 12.01 grams. So here we go. We're going from moles to grams. We do not want moles in our final answer. We want grams. We're going to put it over 1 just because it's our initial measurement. Bring down moles and label the element. Trust me, for the future, you're going to want to label everything. Moles of carbon, and now we can go to grams of carbon. Using the molar mass from the periodic table, we can say 1 mole of carbon equals 12.01 grams, and it ends up being a multiplication problem. 1.6 times 12.01, the answer would be in grams. The moles cancel out, and the answer would be 2 sig figs. Okay, after the pause, I've changed it up once again. This is going to be converting from grams to moles this time. We're going to have a number in grams, and we're going to get it into moles. You're simply going to divide by the molar mass from the periodic table. I'm going to make up a number. Let's use, what did we do last time? I did carbon, right? Let's do carbon again. But I'm going to start with a number in grams. Let's say I have 15.6 grams of carbon. I want my answer to be in moles. So I'm going to set up a dimensional analysis solution. 15.6 grams over 1. I want my grams to be down here. I'm going to convert from grams into moles using the molar mass. That's me labeling. In 1 mole of carbon, there are, from the periodic table, 12.01 grams. It ends up being a division problem. 15.6 divided by 12.01. Your answer would be in moles because grams cancel out. Moles of carbon, and the answer would be 2,366. Hey, Honors Chem, back with you. By the way, the answer to that last problem was 1.30 moles of carbon. But we're going to put it all together right now, and let me turn you. We are going to convert from grams through moles into atoms. The previous segments that I showed you, we went from atoms to moles, moles to atoms, or I should say particles to moles, moles to particles. We also did grams to moles, moles to grams using the molar mass. What we have here is an example chemistry problem, and this is why I like the mole and these sorts of calculations, because you can take something that's very, very real to all of us, and we can figure out from a mass in grams how many atoms there are. As you can see, I decided on a penny. Let's pretend we have an old penny here, pre-1982. We're going to assume that it's made entirely of the element copper. The question is, how many atoms of copper are in a 2.5 gram penny? We cannot go from grams directly to atoms in one step. Every chemical, every substance has a different molar mass. So what you have to do is go through moles because it's an amount, 6.022 times 10 to the 23rd units. So what I'm going to do is put everything together. This is going to be a multi-step solution. We're starting in grams of copper. I'm going to cancel out grams. I'm going to use the molar mass and go from grams into moles. And then on a separate fraction that I haven't drawn yet, we're going to convert from moles directly to, in this case, atoms, because we're dealing with a single element. So picture a penny. One single penny, it has a mass of 2.5 grams. Let's figure out how many atoms there are in that penny. I'm first going to bring down the unit, not the number, the unit, grams. Grams of copper. I'm going to use the molar mass, which is on the periodic table, and I'm going to convert grams into moles. Grams on the bottom, grams of copper on the bottom, moles of copper on the top. From the periodic table, the box in the periodic table for copper, we can say that 1 mole of copper has a molar mass of 63.55 grams. If we divided this out, that would cancel out grams, and we'd have our number of moles of copper in a penny. But we don't want moles. We want atoms. We want particles. So we have to keep going. You can do all of this in one long solution. I need to make sure I don't run out of room here. Grams has canceled out. We're now in moles. We need to cancel out moles. There's moles of Cu on the bottom. We can now use Avogadro's number to go directly to atoms. Avogadro's number tells us that in 1 mole of copper, in this case, or anything, there would be 6.022 times 10 to the 23rd. Once again, I have no room for myself. That always happens. You can multiply across the top if you like, then divide by this. I like to use the shortcut that I mentioned in class when we did dimensional analysis. I would go 2.5 grams divided by 63.55 grams. Grams would cancel out. We don't need to worry about our ones. Moles will cancel out. And it's going to end up being this divided by this times this. The answer would be in atoms of copper. We're going to go to 2 sig figs, and I'm going to pause it because I'm going to actually calculate the answer. Okay, like I said, 2 sig figs. The answer is going to be 2.4 rounded times 10 to the 22nd atoms of copper.